Elasticity and scalability are two crucial factors that ensure the operational continuity of a business, especially when user demand for an application fluctuates. Thus, if there is an unexpected increase in user requests, the application will not be overwhelmed or collapse, but will continue to function optimally. However, what happens if there are alterations in the components that support the execution of an application? Let me explain this point. When a user provisions an application, it runs with the help of underlying infrastructure components, but a service interruption may occur when some part of these components needs maintenance, such as replacement or upgrade, because in such situations it may be necessary to shut down or restart the servers. In this case, users may experience significant application downtime during this time. Therefore, the purpose of high availability is to minimize application downtime and maximize uptime, that is, to keep the application available as long as possible, hence the term high availability. So, to achieve this, we set up a planned failover of the application to another node before performing maintenance on the servers. It is called planned failover because we can prepare it in advance before performing the replacement or upgrade on the servers. The application can be in a running state and accessible to users during failover. The user may not even know that the application has been migrated from one node to another. It is quite seamless and transparent to them. Once the maintenance is done, we can configure the application to return to its original node, again, without any interruption to the users. Therefore, the downtime in planned failovers is practically zero, ensuring high availability of the application. Now, there is another type of service interruption that we cannot plan for, and that is the failure of any component of the underlying infrastructure. Failures are sudden and can occur without warning. Whatever the failure or its cause, the application may be inaccessible during that time. To achieve high availability, it is best not to wait for the failure to be resolved. Instead, the first thing we should do is to immediately set up an unplanned failover of the application on another node and then redirect users to this new instance of the application. So in this case, it is called an unplanned failover because we can never predict a failure. It is very likely that users will know something is wrong for a while. Then, once the failure is fixed, we configure the application to switch back to its original node. The downtime here is greater than zero, but because we did not wait for the bug to be rectified and immediately started an instance of the application on another node, the application can still be highly available with minimal downtime. Know that service uptime is defined in a document called a Service Level Agreement, or SLA, and is measured as a percentage. For example, if a service claims 99.999% uptime in its SLA, that is, 5 nines because there are 5 nines, the downtime is 0.001%. This translates to approximately 5.5 minutes of downtime per year. For context, a year has more than 500,000 minutes, 525,600 minutes to be exact. Applications that use several services have a composite SLA, which is calculated by taking into account the SLAs of each service they use. The customer has to calculate it in IaaS and PaaS because it controls the architecture of the application and the services it uses. But in SaaS, the cloud service provider will define it for you. So, remember that high availability is measured over a period of time, and AWS also offers high availability services.